This one is starting out as a Twitch exclusive, twitch.tv/smAsho. We're counting down to the solstice. So only 25 days until summer in the Northern Hemisphere, winter in the Southern Hemisphere. What are you doing with your final few weeks? We'll be streaming live at this moment, 11:32 and 9 seconds Eastern Daylight Time. That's 11:32 p.m. on June 20th, Sunday, June 20th. Also, there's a total lunar eclipse coming, and it's only a very short period of time away. Maximum eclipse happens at 7:18 Eastern Daylight Time, and there's where you'll be able to see it. Shout out to Kimberly. Perhaps she'll get some photographs of the total lunar eclipse for us to feature on the channel. By the way, thanks to our YouTube subscribers. Don't forget to check our other cosmology segments. There's a massive playlist with like 200 videos on cosmology in that playlist. youtube.com/smashamash/playlists for all kinds of data besides, all kinds of content besides the daily space weather. Also on BitChute, you can find some exclusive content there. If it was demonetized on YouTube, it's on BitChute exclusively. Also, check out our own webpage, smashamash.com. Smashamash.org will redirect you. Today's featured store is the Smash Store, linkable there. And this is what it looks like. We've shown a hexagonal lattice structure, and our regular viewers are fully aware as to why that is. And it's because condensed matter matters. So check out our products there. Today's featured product is the 3C405 Bagashov edition shirt, and we've shown it here in Carnation Pink. Since Mr. Bagashov doesn't like my graphic design work, we've made a special edition with extra girly colors just for Eugene, available in pink, another pink, and white if you're feeling virginal, the 3C405 shirt. More about that in a moment. 3C405, massive radio galaxy, Cygnus A. Next, I'd like to thank our patrons, as they are the main source of funding for this content. Thanks again, patrons. Please consider being a patron at patreon.com/smashamash. You'll get all kinds of alerts and all kinds of information, science articles, and so on that nobody else gets. Multiple tiers available there. Patreon.com/smashamash. Thanks again, patrons, for increasing the probability that these videos will continue to exist and remain publicly visible. Today's cosmology segment's got a series of interesting stories. Let's do it. Are you familiar with the problem of the coronal heating? Why is it that the corona, the much more diffuse atmosphere of the sun, is so much hotter than the photosphere? How come the photosphere appears to only be 6,000 degrees and the corona is like 2 million degrees? What's up with that? How can it be a thing? Are there problems with estimating temperatures? Are there problems with estimating the density of portions of the sun? Is the sun made of condensed matter instead of a gaseous plasma? And what about the ability to even measure temperature? Now, Alfvén waves are one of the explanations for what can be going on in the corona to make it so hot. I just wanted to scroll the article here to bring this up, as the coronal heating problem is an issue. So one of the explanations to this is that the sun is made of condensed matter, and that there are, well, I don't want to get into it, but why is it that the sun's atmosphere is so much hotter than the sun's surface? I like the way the article is referring to it as a surface also, as the standard concordance model of the sun features the sun not really having a true surface. By the way, today we're not going to pick any random numbers. We're going to take a look at 3C405. So this is the massive radio galaxy featured on the shirt that we showed you, the 3C405 Bagashov edition. And we're going to be having Eugene on the channel soon. As it turns out, he has a sun blog. We want to hear all about it. Anyway, this is massive radio galaxy 3C405. And what's interesting about this one are the radio jets. So you can see these lobes here. These are associated with jets that appear to be blasting relativistic particles out of the galactic core's poloidal fields, the poles of the galaxy. And You can see some spots where there's probably some precession happening. You can see this area of condensation and this area of condensation. This view here is X-ray spectra from the Chandra. Chandra took some very detailed imagery of Cygnus A. Now, this is also the most massive radio source in the entire sky, second only to the Sun. In other words, it's the strongest radio source despite being at an estimated distance of about 530 million light years. It's far away, and it's sending us the strongest radio signals of any object in the entire universe besides the Sun. We'll also show you it in red. There it is in red light. And here it is in blue light. Massive radio galaxy Cygnus A, also known as 3C405, featured on one of our products and on our website. Here's another interesting object. This is AG Carinae, a supernova remnant believed to be about 10,000 years old. And it's a massive nebular supernova remnant. I would also note the box-like shape to it, the way you can see like 90-degree angles in here. It's quite interestingly shaped, perhaps giving us insight into some of the forces at play to give it this sort of structure. And this was taken on the 31st anniversary of the Hubble. It's the astronomy picture of the day. You can look at it yourself if you head to apod.nasa.gov. One more thing to talk about, the precession of the galaxy. Yes, all spinning objects precess, folks. And what we're looking at here is the polaroidal axis of the Milky Way galaxy. And the Milky Way galaxy appears to be warped. And one of the explanations of this warping is the precession of the galaxy. It wobbles as it orbits. And what happens is its axis points at different points around this circle as it precesses. Imagine a spinning top. When a spinning top spins, it wobbles back and forth. So does the Earth, so does the Sun. And precession is super important in terms of how these things are behaving, as there is a relationship between their polar field output and their precessional wobble, in that when their pole is aligned with their magnetic field, they output more material than when it's not aligned with their magnetic field, and the precession is what aligns and unaligns the output of a galactic core with its magnetic fields. So does the Milky Way spin like a top? It looks like it probably does, and this is an explanation for the observed warp in the Milky Way galaxy. As the Milky Way galaxy is not a flat disk, it is a warped disk. And here's a sort of a crude animation of the warping of the Milky Way galaxy as its precession goes on. And the idea here is that perhaps it is a different time scale than initially thought. You can find this article on phys.org in the Astronomy and Space section. Does the Milky Way move like a spinning top? And most likely it does. Another interesting article here, prebiotic ethanolamine found in a molecular cloud near the core of the Milky Way galaxy. So this is the building block for cellular membranes, folks. A huge cloud of ethanolamine near the galactic center. Is it because there's life floating around near the galactic core of the Milky Way galaxy where there's lots of radiation and lots of busy things going on? Perhaps. It is a prebiotic substance. So another interesting article here on the phys.org Astronomy and Space section. And here's one from SciTech Daily. This is also on phys.org. It is a map of the dark matter. So dark matter is believed to be a gravitational inducing force. And while some of us believe in dark matter and some of us don't believe in dark matter, perhaps there is some other force at work, or perhaps there is something going on at cosmological distances that is not fully understood. So these are just diagrams of the local intergalactic region here, folks. You're looking at about 20 million megaparsecs in the scale of these images here. And it's showing you the X is located at, that's the Milky Way. And I'll just zoom in on these so you get a better image of this. And the arrows are showing you the direction material is moving. So when you see dark areas, those are areas where there's expected to be large amounts of, quote, dark matter, end quote. There you can see M81 and NGC 5128 are at the two ends of the Milky Way's local filament. And you can see these filamentary structures here associated with the local galaxies. There's even a filament going through the local void and so on. And here's another diagram showing you the Virgo cluster and so on. And I just picked the SciTech Daily article, "A New Dark Matter Map Reveals Hidden Bridges Between Galaxies." Now, whether you believe in dark matter or not, this is still a relevant map as it's showing you the direction and gravitational influence. So this is where a lot of material is expected to be, assuming that there is invisible material there, creating gravitational fields, causing these galaxies to move in these fashions. And you'll find this one all over the Science Wire today. Whether or not dark matter is a real thing is not all that relevant, folks. This is still relevant, even if dark matter does not exist, because this careful mapping of the motion of intergalactic scale structures is helpful regardless of whether dark matter is proven to be real or not. So that's today's Cosmology segment. Thanks for tuning in. And don't forget to press like and subscribe if you're viewing on YouTube. Thanks to all of our viewers, wherever you're viewing our content. I've been your host, Dan, a.k.a. smAsho.